Hi everyone. Today's class we are going to see about the nanoelectronics and its introduction. What is meant by nanoelectronics and what is the size of a nano? Okay, you may be having many questions in your mind. You look at this picture, the real-time picture which I wanted to correlate with your understanding with the nano size. The tennis ball you take, we are able to see real time what we use the tennis ball, the size. The scale which is plotted there in this figure, it clearly shows that is there in the nanometer scale. Okay, the size of the tennis ball, then it is moved to a period, then the cancer cell, then bacteria, virus, antibody, glucose, water. So this is the scale which we have. The red mark indication, it clearly shows it is working there in the 10 to 100 nanometer level. Okay, this is actually a size. Okay, it is very tiny in the nature. How will you correlate this nano there in your real-time picture? Again, I wanted to show one figure, okay, which is very much comparable with our human hair. When you take our human hair, okay, you keep it on your hand and see how the structure of the human hair, okay, or what is the size of the human hair. Okay. I'm going to compare this human hair with nanofibers. Look at this figure actually. Nanofibers are, many nanofibers are plotted there, and the human hairs are placed above the nanofibers. Okay. If you compare, okay, how the thickness of the human hair, if you look at through our naked eye, okay, it's very small. But if you compare with the human hair, okay, the human hair become very big. Okay, so imagine what is the size of the nano which we are working for our systems. Okay, so you would have got some figure out idea about what is this size of the nano. Okay. And what is this with working with the electronics? Okay, that is called as the nanoelectronics. I'll show some fundamentals behind the nanoelectronics. Okay, the fundamental components which is involved there in the nanoelectronics is actually devices. Any devices which consist of actually three terminal, we are going to work with a basic three terminal device. That's we call it as a transistors, source, drain, as well as the gate. Okay, that is a channel. Okay, the gate we call it as actually voltage source which we have applied there. Okay, we have source, drain on the channel. Okay, gate is going to be a controlled one, of course. Okay, this dimension of this transistors is there in the micron level earlier. Okay, then that is moved to a nano level. Even it is scaled down, now we are going to scale down furthermore. Okay, that is what the scope of this structure. Okay, what is this all about, this transistors, and how we are going to build the system? Okay, you got an idea about this transistors is there in the nano level. Okay, the dimension of this transistors there in the nano level. If two transistors are combined together, it will form actually a gates. Okay. We all have studied about many types of gates. One is your AND gate, NAND gate, XOR gate, OR gate. Many types of gates you have studied. Okay, these gates are built by these transistors. Two transistors combined together forms a gates. Then many gates combined together forms as a circuits. Many circuits combined together and forms as actually modules. Then these modules combined together and forms as actually a blocks. Then many blocks put together will form this actually a system. Okay, this system we can call it as actually fully integrated systems. Okay, that is what actually your evolution of your IC. All your electronic components which we are having there and with us, it's made by actually integrated circuits. What is this integrated circuits? Basically it starts from the devices, then devices moves to a gates, then from the gates we go for a circuits to the modules. Okay, so your transistors are going to be major roles there which is present there in your systems. So you got the nano size of transistors are put together and forms as a systems. I'll show one small idea for you. Okay, this is actually a 3x3 one structure. Okay, how the system looks. Okay, take actually many type of transistors are packed there on a same integrated circuits. Imagine, okay, 1 micrometer devices, okay, are packed there on this blocks, okay, and then the billions of transistors will be packed there on this same block. Okay, one transistors to the gates and gauge to the circuits. This all forms actually this complete blocks. You take this complete block, we will call this is actually a billions of transistors are packed on a single block. Okay, so the size of a transistors are playing major role while you go for actually a system development. Okay, not only this, we have other two parameters we need to keep there in our mind. Okay, the next slide I'll show that. Okay, the new perspective which is present there in the nano, one is actually a transport mechanism. Okay, what is meant by transport mechanism? The charge carriers which is taken from one node to the other node. Okay, that is what we call it as a transporting of a charge from one node to the other node. Okay, here you take an electron. Okay, electron which is a charge which is carrying and moving from one node to the other node. Okay, the earlier system which we use, there is a diffusion system. What is called diffusion system? The electrons are present there. The electrons take a start from one place, it moved to another end and reflected back, going one end, coming back, going end. This all happens there. Okay, that we'll call it as actually a diffusion type. Okay, that will be reflected and the diffusion operations are taking place there in the system. Okay, it will take a long path to travel. The point you should understand there in the new perspective, our nanoelectronic systems is not going to follow the diffusion process, it is going to follow the ballistic process. But what is called ballistic process? It starts from one node, okay, it will straight away like a rocket, okay, it will travel very quickly with a very fast node, okay, it will not take a scattering operations there in it. Okay, this is actually a old dimension of a transport property as well as a new dimension of this nano system properties. Okay, so if you take this, okay, you would have got some idea about what is the speed of the factors. Okay, charge carriers are the speed which is playing a role there in the devices. Okay, if we take a diffusion system, it will take a long path to travel, so long time it will take, so your speed component become less. But if you take a ballistic operation, it will quickly travel, so the speed become very high. Okay, so the second parameters also it is done. Okay, so this is not the other parameter we need to keep there in our mind. We have another one parameter that is called a low power. See, any system you develop, we need to consider about the power optimization of this. Okay, what is the power utilization of my device? Okay, if you go for a nano system, still it is very fast in nature. Okay, size is also less. Okay, the resistivity property gets changes. So automatically the power utilization by the device is also going to get reduced. So three factors we keep there in our mind while we go for a nano systems and the nano electronic new perspective. One is the size component, another one is the speed component, another one is the power component. All these three components we are playing a major role there in the nano electronic devices. Okay. With this, I'll take a few applications which is present there in the nano electronics. First one is actually a very popular applications which all the human beings are looking for now is the medical applications. Can a nano electronics can be make some impact on the medical devices? If you ask the question that is exactly yes, because all the electronic devices, what we do if you go to hospital, if you go to some other operation theaters or anywhere, okay, it consists of all the electronic devices. If these devices are going to get replaced by the nano electronic devices, okay, some applications are like cancer cell detections. Okay, you wanted to detect some cancer cells, the detectors are used. The detectors are made by actually a nano electronics devices. Okay, that is a detector. Okay, that is a sensors. Okay, the nano materials are involved there in it. Okay, then you if you wanted to measure some blood pressure or you wanted to measure some blood vessels, what is the pH range, all these things can be measured using the sensors. Okay, the tissue engineering is one of the areas where actually nano electronic devices plays a role. Okay, this is for your medical applications. Then next one which I am looking is for the energy applications. If you have this energy applications, what are the applications can be correlated? As I said already, okay, energy is a major area actually the whole world is looking now. Okay, we cannot waste a small amount of energy wasted there in the system. Okay, so we need to be very cautious there in the energy utilization of it. Okay, some areas where nanoelectronics materials are looking is actually a solar cells, photovoltaic nanomaterials are involved in it. Okay, to save more amount of energy into it, and further internal utilization can be taken place. Okay, then hydrogen fuel cells is one of the hot area. Actually, many are working on it. Then the low power circuits. As I said, see, we are packing more number of devices in the system. Okay, if your small device, if it is there in the 5 nanometer device, okay, if you are going to pack for billions of transistors, okay, the power utilization you imagine, okay, it will be completely reduced where you go for a micron level devices. Micron level devices are very big in nature, so automatically consume more amount of energy. But wherein if you come to this nano level system, small devices, it will cover only little amount of power. It's compared with the micron devices. So all the electronic circuits we wanted to replace with the nano electronic devices. Okay, that is one of the area actually all the electronic engineers are now working, as well as the semiconductor industry is also looking at. Okay, LED is one of the area actually all the people are looking. Okay, LED, various type of LEDs are present there. Okay, if you come to the third type, that is electronic device, another electronic part I wanted to discuss. Okay, memory. Okay, any memory systems is consists of a transistors. Okay, you take a SRAM or RAM or ROM or DRAM, any kind of memories you take. Okay, their electronic devices are used. Nano electronic devices are used. Your capacitance factors plays a role. Capacitance bigger, then you will get actually more memory utilization. Molecular transistors, then nanotubes. These are all the very hot area actually. Many people are working on it. Memory chips, okay, is one of the area actually electronic devices are looking. Sensors, okay, nanoelectronic sensors are widely used in agricultural applications and bio applications, okay, aerospace applications, okay, cryogenic temperature operations. These all things can be worked there in it. Okay, then the important point I wanted to highlight there. Now we are working out with a solid based systems. Okay, all semiconductor materials are solid in nature. You take this one. This is electronic component. It is solid in nature. Suppose this is going to be ruled next by a flexible system. Okay, there comes actually nano materials are playing a role. We want the solid devices to be changed to a flexible system. Okay, flexible system, I can easily fold this one and I can keep it in my pocket or in my bag easily and I can walk. Okay, I doesn't want to carry a very bigger substance with me. Okay, so people are looking for a flexible system. In turn, this flexible system will move to the next important area. Next to the semiconductor industry is looking, that is actually biodegradable system. You all experience this kind of examples in your house or in your workplaces or any places where, see, if you look all the mobile phones which we use, okay, you have changed many mobile phones several times. Okay, but can you able to destroy that mobile phone? Earlier mobile phones, you see, it is still stored somewhere as actually a what to say, as a junk. Okay, we are not able to destroy it. We wanted to give the solution for it. There comes actually a nano systems in the future. It is going to be a biodegradable system. Okay, not only with the solid to flexible, flexible to actually a biodegradable one. So we can make our earth very eco-friendly environment in the case of all the semiconductor devices. So with this, we have got a brief idea about what is nanoelectronics, what is the fundamental of nanoelectronics, what is the primary component involved there in the nanoelectronics, and what is the applications present there in the nanoelectronics. Okay, next I want to tell, lithography is also involved there in this application point. Okay, with this, I will try to conclude this class. Okay, you have any queries or any doubts, you can post to me. I am ready to answer the queries for it. Okay, thanks for listening the class. Okay, thank you.